Okay guys, so this video is going to be like a supplement or an additional video from me to help explain graphing quadratic functions. It's kind of going to cover 6.5 and 6.6, but I'm kind of going to go in a weird order. So I'm first going to write down the vertex formula of a quadratic, because I like starting with that. So f of x or y equals a times x minus h squared plus k. So this is called vertex form. So this form is called vertex form because you can very easily identify the vertex of the parabola by literally looking at your formula. So the vertex is hk. That's a point. All right. So we get that from these values here. Now, I want you to remember this little catchphrase here. Change the h, keep the k. And what does that mean? So notice that h is in the parentheses. K is not. So let's say that I wanted to, if I had this example, f of x equals 2 times x minus 3 squared plus 1, and I want to find the vertex. Well, this is in vertex form, so I can just look at my equation and find the vertex. Now, change the h, keep the k. So change the h. What does that mean? So right here you see x minus 3 in parentheses. But I want to change the sign, okay? So h is going to be positive 3, and I'll show you why in a second. That's what change the h means. So change the sign of the number you see here in parentheses. Keep the k means, what do you think? Keep the k the same. So k is going to equal positive 1. Okay? So the vertex is going to be 3, 1. Now let's say that I knew that a is 2, just because I'm telling you that. So why is it change the h, keep the k? So if a equals 2, and I know that h equals 3 and k equals 1, let's plug it into our vertex formula. Okay, so that would be f of x equals 2 times x minus 3 squared plus k, which is 1. And you see how this is exactly the equation we started with. If we said that h was negative 3, if we said that h is negative 3, then if we plugged it in, we would actually get something different. We would get x minus negative 3 squared plus 1. And we know that x minus negative 3 is actually x plus 3. That's a completely different equation. So that's why we do not say that h is negative 3. So we change the h, keep the k, to identify the vertex. Okay? Now, this also tells us our horizontal and vertical shifts. Alright? So, if your h is 3, that means you're going left or right 3. You're going right 3 because it's positive. If your k is 1, that means you're going up 1. Okay? So this form is super helpful because it tells you not only the vertex of the parabola, it also tells you your horizontal and vertical shifts, as well as a few other things. but this is how I like to start off talking about quadratics. And so this is actually kind of mentioned in 6.6. Then they talk about shifts, but I like to talk about this first. All right, so let's practice a few more. So let's say we have, so first let's focus on the parent function. F of x equals x squared. So what does that look like? Let's make a table. So we have x and f of x. So let's say we have -2, -1, 0, 1, and 2. Let's plug in these values into our equation. So that'll be -2 squared, which is +4, -1 squared, which is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So let's graph that. So when x is -2, y is +4. When x is -1, y is +1. When x is 0, y is 0. When x is 1, y is 1. And when x is 2, y is 4. If we connect those dots, we have a parabola. Okay? This is called our parent function. Whoa, I can't write today. Let's try that again. Okay. There we go. So this is like your starter function, and then your transformations, your shift left or right, up or down, whether you open up or open down, is based firstly on the starting point, which is the parent function. So let's look at f of x equals x squared plus 1. So this plus 1 is like your k, okay? So that tells you that we're going to take this exact function and move everything up 1. So this would go here, this would go there, this would go here, and this would go there. So you would literally shift everything up 1. What if it was, I should have made that g of x. Make it a different letter. G of x. Okay, what if we have h of x equals x squared minus 4? So our parent function's in black, so we're going to shift everything down 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this would be the parabola in green. Okay? So the K determines your vertical movement, up or down, from the parent function. Okay? So now let's look at horizontal. Let's say, I don't know, I need another letter. M of x. So that's going to be the h coordinate of your vertex. So that's going to be in the parentheses, x plus 1 squared. So remember, in the parentheses, remember we changed the h. So this tells me I'm going to go to the left 1 from the parent function, because you change the h, change the sign. So we're going to go to the left 1, go to the left 1, go to the left 1, left 1, left 1, There is that parabola. It's going left 1. If we have another one, k of x equals x minus 5 squared. So we change the h, change the sign of the parentheses. We're going to go to the right 5. Starting from the parent function, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there is your graph. Okay? And then you can combine those two, left or right, up and down together. Alright? So let's look at that. So first let's graph our parent function of x squared. Okay, so that's going to be like this. And again, you can get these points by making a table. So now let's combine it. Let's say g of x equals x minus 2 squared plus 1. Okay, so this minus 2 is going to tell me how I'm going to move horizontally. And that's also the x coordinate of your vertex. Well, remember, you change the h. Okay? So that's going to be h equals positive 2. So we're going to go to the right 2. Plus 1 is your vertical up or down shift. That's your k. Change the h, keep the k, so k equals 1, so we're going to go up 1. So we're going to do a combination. We're going to go to the right 2 for everything and up 1 for everything. So we would go, starting here, we'll go to the right 2, up 1. Let me use a different color. Right 2, up 1. 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 And there is your graph. Okay? Now, let me show you a shortcut for graphing quadratics that have horizontal and vertical shifts, or any shifts. Okay, so again we have f of x equals a times x minus h squared plus k. So what I like to do is I like to create what's called a new Okay, what is happening? Okay. I'm gonna call a new origin. I'm making this idea up. So I'm going to grab the vertex. So if I look at, so that's your H and K. Okay? And then once I grab the vertex, that's going to be my new starting point, my new anchor. And then from there, I can just do my regular parent function, but from that new origin. So let me show you what I mean. So let's say we have f of x equals x plus 2 squared minus 3. So the first step would be to get the new origin or grab the vertex. So the vertex of this function, change the h, -2, keep the k, -3. So that's your vertex. So what I'm going to do is plot that vertex first. Let me make some grid marks. If I plot the vertex, x equals -2, y equals -3, so my vertex is here. Okay? When I do that, I can actually just then take the parent function here and graph this. Well, don't forget the squared. Graph this starting from my new origin. So remember my little table. We have when x is -1, 0, +1. I'm just going to use 3 points. So that would be -1 squared is +1, 0 squared is 0, and 1 squared is 1. So if I start from the new origin, which is this dot in purple, and I go left 1, up 1, 0, 0 is the vertex, and I go right 1, up 1, I've actually graphed the original function because this new origin, this point here, took care of my horizontal and vertical shifts. Okay? So this is like a shortcut way of graphing a quadratic equation.